Let's take a look at some of the ones in number 19. You're given the graph of the function f of x, which is the red curve. It's kind of piecewise defined. There's some line segments, and then there's a curve here that looks like, well, it's part of a circle, right? Half of a circle here, and then continues on. I'm going to look at 19e, which is to evaluate the definite integral from 1 to 4 of the function f of x. Okay, so we're going from x equal 1 to x equal 4 over that interval. So what's happening? Well, kind of break it up into two parts, right? From 1 to 2, the graph of the function is below the x-axis, right? And remember what that means. The definite integral will evaluate this region, this triangular region here, what I'm calling region 1, as a negative quantity, right? Because when we're doing our rectangles, right, picking our right endpoints or whatever endpoints we're using and evaluate the function, we're going to get negative values, right? Negative values times delta x is, negative times a positive is negative. Add them all up, you'll have a negative result. So it's just the negative, this area, and this is a triangular area. And so therefore region 1 is going to evaluate as negative what? 1/2, the base is 1, that's the from 1 to 2, and the height is 4, right? 4 units. So negative 1/2 times 4 is -2. So region 1 is going to accumulate, if you will, as -2. And then region 2, though, the function is above the x-axis. And so this region here that I've got is going to be positive area. All right, so this area in here. And what is that? That's a quarter of a circle. And so for region 2, since we're above the x-axis, 1/4 of a area of a circle. What's the area of a circle? Pi times the radius squared. What's the radius of this circle? The center is right here. And so going up or going over, we see that the radius is 2, right? The distance is 2 all the way around. So it's just this 1/4 of the circle. So it's 1/4 pi r squared. Well, r is 2. 2 squared is 4. 1/4 of 4 is 1. So I just get pi. Okay, so the integral from 1 to 4 is the sum of these two parts, right? Area region 1, area region 2. So area region 1 is -2, area region 2 is positive. And when I say area, I mean, of course, the signed area. So -2 plus pi is the same thing as pi plus a -2 or pi minus 2. So these are equal to each other, which is about 1.14. Do a couple more like 19i and j. So these are not exactly 19i and j, but they're very similar. So same function though. I'm going to look at the integral from 0 to 1 of 3 times f of x. So what do I do with that? This constant multiple by the properties of definite integrals can be pulled outside, right? So it's 3 times the integral from 0 to 1 f of x dx. We can only pull it outside if there's no variable, right? The variable of integration is dx here. I should have a dx here, right? The dx tells us rather the variable of integration is x. And so we have to leave that there. But now from 0 to 1 f of x dx, so we just use the area to, geometric interpretation of the area to define what the integral from 0 to 1 is. Of course, from 0 to 1, again, our graph is below the x-axis. And so this rectangular region is going to calculate as a negative area. All right, and so it's -1. The height is 4. The width is 1. So -4 times 1 is -4. 3 times that integral value of -4 gives me -12. So the original integral from 0 to 1 of 3 times f of x dx is -12. Now here's one like 19j, is the integral from 0 to 1 of f of x plus 5. So how do we deal with that? Can you just pull that plus 5 out like we did the 3? Well, no, you can't do that because we're adding it to f of x. But I can write the integral of a sum of two functions as the sum of the integrals. So the integral from 0 to 1 of f of x plus 5 is the integral from 0 to 1 of f of x plus the integral from 0 to 1 of just 5. Okay. Now the integral from 0 to 1 f of x dx, we just found that, right? We talked about that here. It's -4, right? Because it's this area here. Of course, negative again because it's below the x-axis. So this region here evaluates as a -4. Okay. But then what's this one going to be? Well, there's a property that we talked about that if you are integrating any constant, it's just going to be the constant, which is 5 times the length of the interval from 0 to 1. The length is 1, of course, and you get 5 times 1 is 5. So, why is that? Again, just geometrically, if you think about the graph of the function y = 5, what is that? A horizontal line, y = 5, and going from 0 to 1, you see the shaded in region. The height is 5. The width is 1 minus 0 is 1. So it's just the area of this rectangle 5 times 1. That's exactly where this formula comes from. So -4 plus 5, going back to the original integral now, gives us 1 for that value. So I hope this clarifies some of the ones in number 19 for you.